So there's 3 more videos to this section, and they're all just doing examples. This example after example, okay? So a typical problem would say something like write in simple radical form. So remember, the radical is that thing that looks like a square root sign. It's called a radical. So a to the 5/3. Well, that's a cube root, and a is raised to the 5th power, but it's smarter to write 5/3, since it's bigger than 1, write it as a mixed fraction, 1 plus 2/3. Then write that, so that's going to be a to the 1 times a to the 2/3. And then just write that as a, and write the 2/3 as a radical. See, because then you've already reduced everything. It's in simplest radical form. Okay, so I'm going to do a times the cube root of a squared. Remember, the 2/3, the 3 is the index, and the 2 is the power on the a, the exponent on the a. Okay, cube root of x times the 5th root of x squared. We did not talk about how to multiply something like this before, but we can do this easily with the fractional exponents, because all we have to do is add the fractions when we multiply using that rule of multiplication, right? So the cube root is x to the 1/3, and the 5th root is x to the 1/5, and we're squaring that, so it's x to the 2/5. And now we just have to add 1/3 and 2/5. We need a common denominator, which is 15, right? So multiply the first one by 5/5 and the second by 3/3. Write them both as 15ths, and I get x equals 11/15. Rewrite that. It said you have to look at what form they wanted the answer for. That's the one tricky thing in this section. You always have to look for what do they want it in fractional exponent form or in radical form. Actually, they don't usually say fractional. They usually say rational, and that can be confusing because the RA in rational and the RA in radical. So be careful. Radical means that square root thing, the square root sign. Rational means an integer over an integer. Rational exponent is the exponent is an integer over an integer. Exponent is a rational number. So they did not ask for it in rational exponent form. They asked for it in radical form. So we have to convert this x to the 11/15. It's going to be the 15th root of x to the 11. Okay. Once you get this pattern down, not hard. Of course, you have to be able to add fractions, but these aren't very hard fractions. Again, if you have trouble with that, then you need to review stuff from chapter 1. 4 times x to the 2/3. I'm supposed to write this in simple radical form. Well, 2/3 is less than 1. The 2/3 power is less than 1, so I won't do that trick I did with number 1, example number 1. I don't have to do that. So I can just directly convert it. So it's 4 times the cube root of x squared. The important thing here is that the 4 is the coefficient of the whole thing. It's not being raised to the 2/3 power. In order to do that, I'd have to put the 4x in parentheses. Okay, which I did here. So this is completely different. Now I have to raise the 4 to the 2/3 power, and I have to raise the x to the 2/3 power. So I wrote 4 as 2 squared. Why? Because I'm going to multiply the 2 by the 2/3, and I'm going to get 4/3, and that'll simplify. It's just a little easier than writing 4. The cube root of 4 squared would not be simplified. Okay, so I end up getting 2 to the 4/3, which I can write, and I converted the x to the 2/3 to the cube root of x squared. And then the 2 to the 4/3, I can break up like 1 1/3. And you could do this in your head if the numbers are simple enough. Right, 4/3 is 1 1/3. So from that I get 2 times the cube root of 2 times the, right? And the cube root of 2 times the cube root of x squared. Since they're both cube roots, I can just put those together like that. So that's one way to go about doing it. I mean, there's other routes you could take with this that would be fine, as long as you come up with this answer. Remember, the answer has to be in simplest radical form. Okay, and this is my main point with examples 3 and 4. These are not the same, so don't get confused if you see this exponent that it's going to be raised to the 2/3 power too. No, it's not. I have to force it if I want that to happen by putting parentheses in. So these two are completely different. See, the answers are totally different. What's the difference? Well, this one, the 2's inside, and this one has a 2 outside, right? This extra 2 is inside or outside, and there's a big difference. This is a cube root of 2, and this here is 2 times actual 2, not the cube root of 2. So anyway, those are different, so don't get them mixed up. So another kind of problem you could have is write with fractional exponents and simplify. Well, it's really just the same thing. It's just, how do you do a 5th root of a cube root? We never talked about that. So we don't know, so we'll do the powers, right? We'll do the fractional exponents instead. Or rational exponents is what it should be called, really, rational exponents. Although this works with any fractions, actually. Well, the nth roots have to be, n has to be a integer, 2 or larger, right? So that's 1/15, x to the 1/15. And that's what they wanted. They wanted the answer with fractional exponents or rational exponents. They did not say to write the answer in radical form, right? So that's the kind of answer they want. So you have to pay attention to that. So we have 2 more videos like this of just examples.